Hello student, welcome back. Today I am going to discuss about class 9 physics topic graphical representation of equation of motion. Means derivation of equation of motion with the help of graph. These are equation of motion. First equation is v is equal to u plus at. Second is s is equal to ut plus 1 upon 2at square. And third is this. We can prove these equation with the help of graph. This graph is velocity time graph. In x-axis we represent time and SI unit of time is seconds. We have already discussed about time. And in y-axis we take velocity of the objects and SI units of velocity is meter per second. Dear student, to proof of equation of motion, we can use velocity time graph. This graph is velocity time graph. An object travel initially with velocity of u. An object is at position A with velocity of initial velocity u and move along a straight path with a uniform acceleration, and at position B final velocity of that object is v. At this position B final velocity of the object is v. We can derive all these equations with the help of this graph. Dear students, here initially objects OA, initial velocity of the object is u, and after time t final velocity of the object is at point B and final velocity is v. So here finally we can write Vd is equal to v. Dear students, we have already discussed about acceleration. Acceleration is change in velocity per unit time. So here initial velocity of the object is u and final velocity is v. We know that acceleration means change in velocity, means final velocity minus initial velocity upon time. So here final velocity is v and initial velocity is u and t is time second. So now we can conclude that A is equal to v minus u upon t, and after cross multiplication we can find v minus u is equal to at and v is equal to u plus at. This is first equation of motion we have proved with the help of this graph. Now we have to derive second and third equation. Dear students, to calculate or derive equation of motion, second equation, we will find total distance. Total distance is represented by s. According to graph, total distance measured by any objects is equal to the area of that figures. So here we are getting figure of quadrilateral, and distance traveled by the object will be area of quadrilateral. In case of graph, always total distance is equal to area of that figures. So here figure is of quadrilateral. We can find area of quadrilateral with the help of this is, we are getting two figures. First is rectangle and second is triangle. So here area of rectangle plus area of triangle. Dear students, we know that area of rectangle is equal to L into B and plus area of triangle is equal to 1 upon 2 base into height. So this figure is of rectangle. Here length is equal to OD. OD into, and breadth is equal to OA plus 1 upon 2. In case of triangle, base is equal to AC and height is equal to BC. Dear student, OD is equal to time taken T into OA is equal to U plus 1 upon 2 AC. AC is equal to, this side is parallel to this side, so value of this side will be equal to the OD. So this is equal to T. So AC is T into value of BC. This point is BC. We want to calculate total value of BD is V and this is equal to U. So it will be v minus u, v minus u. So here ut plus 1 upon 2 into t. Now value of v minus u from equation first. From equation first, v minus u is equal to 80. That is equal to 80. So this is equal to ut plus 1 upon 2 80 square. S is equal to ut plus 1 upon 2 80 square. This is the derivation of second equation. And now we want to calculate third equation. Again, in case of third equation, we can calculate distance of this figure in two ways. First, distance of the figure is distance traveled by the object is equal to the area traveled by the objects. Area of quadrilateral. In this case, this quadrilateral type of this quadrilateral is equal to area of trapezium. This is indicating figure of trapezium. We can calculate this with the help of area of trapezium. Dear students, we know that trapezium is a quadrilateral. Trapezium is a quadrilateral whose one pair of sides are parallel to each other. This side is parallel to this. So area of trapezium. Area of trapezium is equal to 1 upon 2 sum of parallel side into distance between them. Sum of parallel side into distance between them. In this case, 1 upon 2 sum of parallel side. Parallel sides are OA and BD. That is equal to OA plus BD into distance between them, and distance between two parallel sides is equal to AC or OD. We can write OD. Now here 1 upon 2 OA. What is the value of OA? U. And plus value of BD, that is equal to V into OD. OD is time taken, that is equal to T. Dear students, that is equal to 1 upon 2 U plus V. In the place of U plus V, we can write V plus U into T. From equation first, T is equal to, from equation first, in the place of T, we can write V minus U upon this. V minus U upon A. And now 1 upon 2 into V plus U into V minus U. Since we know that A plus B into A minus B is equal to A square minus B square. So in the place of this, we can write V square minus U square upon 2, that is equal to distance travelled S. So now we can write with the help of cross multiplication 2AS is equal to V square minus U square, and at last we can write V square is equal to U square plus 2AS. This is the proof of third equation of motion. Dear student, this is very important topic of your chapters. Motion. Derivation of equation of motion with the help of graph. These are three equations, and to solve in your home, try to solve these equations with the help of graph. And in your next topic, we will discuss about circular motion and non-circular motion. Thank you.